Welcome everyone to the SPHN webinar about the SPHN Connector. So I hope everyone joined last week's webinar where we talked about the semantic interoperability strategy and the way we implement actually graph data in the realm of SPHN to make data interoperable, to actually describe it with a rich semantic and actually be able to link data from different data sets together. So I'm very proud to have today two speakers, Philip Krauss from Accenture and Katie Kalt from the University Hospital in Zurich, who will present you about a central tool we've developed in SPHN to actually enable not only hospitals, but also everyone who wants to contribute data to SPHN, actually to have a central tool here to provide this data in the required graph format, according to the kind of specification which SPHN is giving. So without further ado, I would like to give the floor to Katie, who will actually give us an introduction into this tool and how it enables data providers to create graph data for SPHN.
Thank you, Sabine, for the introduction, and also welcome from my side to everyone. I hope you watched last week's webinar and have some already basic know-how about semantics, and now we are curious how you can implement this one. So what we will cover in this webinar is a little bit more history as a how does the information go into the graph, how was it done at the beginning, how is it done now, and also what are the challenges, especially for the data providers who have to provide this data. And then we'll come to the actual subject and how do we solve it actually with the SPHN Connector. Then I will hand over to Philip, who tells you all about the cool things that the SPHN Connector can do or does for you. And at the end, I'll tell you a little bit how you can get the SPHN Connector and what you need to do, on what kind of tasks you will have, and also how you get started at the end. So you probably have seen this slide in the last week's webinar. This is the three-pillar system from the SPHN, where we have like semantic concepts, and then we have the RDF schema, and this goes then to the projects, and kind of in between from the concepts, you want to build your data in a way so that you can load it into a graph, which we have designed to be RDF some years ago. So all this technology was very new at the beginning, so it has new challenges, and that's what we want to show you here, how you can have your life easier with the SPHN Connector. There's actually also a publication you find here in the slides. You can look it up. So how does the information get into the graph? So at the very beginning, when there was no SPHN Connector, we were tasked to create the pipeline that creates out of the data in the hospital. Most hospitals use like SQL relational databases, and the output should be RDF. So we didn't really had a lot of experience in RDF. Also semantics was kind of a new for most of the hospitals. We didn't really have a lot of experience here. So we were starting to build a pipeline, and every hospital actually designed their own pipeline. So some hospitals, they used like ETL processes, some used Python as a programming language, or C# or Java, depending on what you're most familiar with and what your infrastructure looks like. So on one side, in the SPHN Connector, or in the SPHN universe, we were actually tasked to create a data warehouse where we collect the data for SPHN and put it into a data warehouse, or in other words, a specific data mart in the data warehouse. And from there, we had to de-identify the data because you don't want to provide identifying data to the graph. And then we had the ontology and the pilot documentation, which was presented last week too, where we can actually study what do we need to put into the RDF, how does it look like. And from this one, we had to create some mapping rules, which defines how the structured data will be mapped into RDF concepts. And these mapping rules will then be ingested into a transformation engine we had to build, which, as mentioned, most of us use Python or C# or Java. And then at the end, there was already a quality assurance framework where you can actually take the RDF and validate it to make sure it complies with the ontology we based all the concepts on. This was a bit challenging, so it was partially done and not perfectly. So we had at the end 5 different solutions here. And every project had kind of every hospital had kind of a project to create this one. So yeah, what are the challenges? It's not only that it's kind of a full-blown IT project to create a pipeline like this, it's more a bit the invisible part, which is the SPHN ontology is changing on a yearly basis. So you have new version, you have new concepts, property, maybe have a new value set. Also features, we have a QC framework now we want to integrate, or it changes a version from the QC or so. Then the semantics and RDF, as said, we were all new in this field, kind of. A lot of hospitals don't really have a functionality to de-identify the data. And also we didn't really knew at the beginning, what do we actually need to do to de-identify data? And the biggest challenge probably was the data quality, because if you have a lot of data, a big graph you want to fill, it's a challenge to actually validate this data in a timely manner, especially with the quality assurance framework we had at the beginning. And then, of course, to create this pipeline, this is not something a data provider or hospital would actually do on a daily business. So you may not have a Python programmer, or you don't use RDF libraries to create RDF files and SHACL rules to validate some graphs. So this is all new, and a lot of extra challenges for the data providers. And it ended up with different pipelines. Here's just some examples. Of course, there's more. So there's not only one university hospital pipeline, but it's now in the phase 2 of SPHN. We also have like registries who want to provide data, cantonal hospitals who want to provide data, or even other ones like private physician practice who wants to provide data. And they all have different kind of systems, different kind of know-how, and they want to ingest data into this graph in different ways. So this was the big challenge. And therefore, we decided to kind of provide a tool that helps with everything that could be consolidated into one thing, so that you can actually focus on the only thing you have to do, which we cannot take away from you. So on the left side of these red lines here, you see the pipeline from the SPHN connector, where you can actually ingest data. It will be de-identified, it will be transformed into RDF, and it will be validated. And from there, you would send it to the project spaces to be integrated into a graph. And all this is based on the ontology, the schema we get, validation rules, which are also derived from the schema. then we also have kind of statistical query which help you to validate beside the QC to make sure that you have the right number of patients or the right number of data in terms of ranges of values, for example. And of course, the pilot documentation is always very helpful. So this goes into the SPHN connector together with the terminologies, which will also be used for the validation, which are provided by SPHN. So now what's left is for you actually on the one side, you have to find in your source systems the data you want to, or you need to integrate. So you kind of collect this data out of the source system, you copy it into maybe a data mart, or if you have a data warehouse, into a data warehouse. And from there, you can then just ingest the data into the SPHN connector, which is then quite a simple process. And probably the biggest one is the collection, because you probably also would have to map codes which are maybe assigned differently in your internal source systems than actually the ontology or the data schema actually specifies. So now, having said this one, I would like to hand over to Philip to show a little bit more about what are the cool things in the SPHN connector here.
Yeah. Thank you, Katie. Sharing here as well the cool things about the SPHN connector. And as Katie said, we are taking the schema itself or the ontology, and then we do something you could think of an auto configuration from this ontology. And this ontology should be or has to be SPHN compliant. So it works for the SPHN base ontology, but also works for project ontologies that are for designed with SPHN tools. The SPHN connector can run multiple projects in parallel. So you can have one instance running for different projects. And one of the most goals we are proud of that we achieved is that you can use more familiar technologies, especially for the ingestion. But how does that auto-configuring actually works? And here I took an example that maybe or hopefully most of you have seen already. So it's about the consent. So whether a patient is okay with having his or her data being used for medical research. And this consent has a link to the subject pseudo-identifier, to the data provider institute, and has also the type, a status, a date time, and also, if not necessarily, a template identifier. And this image here is taken from the pilot visualization, what you see on the website, on the official website from the 23.2 schema. And I want to take you through all the steps that you've seen now in the pipeline on a very simplified or easy to digest manner on this example of the consent. So we built some input interfaces, and one is an object-based input interface, so explicitly in JSON notation. And when we take the consent, you can think of bending some edges, actually, so that it looks like already some object-based. So here you see a more or less hierarchical representation of the very same things. You have the consent, and then you have certain properties attached to this object consent, so in the object world of JSON, and then we have the different values here. We also have another input interface, which is used by many of the university hospitals as well. It's the tabular interface. And also here you can think of like bending some edges, but just in a different direction. So principally, we are having the consent here in the middle of the graph world, and then we take it to the left, and then we make columns. So there will be a column for the hair status code, column for the type code, a column for the date time, subject pseudo-identifier, data provider institute, and a template identifier. And this is just for this very simple concept, but it works for all of the concepts in this way. Now we have data in our input interfaces, and the university hospital fill these input interfaces with the clinical routine data. So we fill in the graph. So the next thing we would need to do is, or this is actually an example filling of the consent. So here I just picked some random allowed codes. So for example, here there's the type code SNOMED, which is specific consent. It's accepted. It has been a datetime, and the subject pseudo identifier is not really subject pseudo identifier now, but it might be even a real patient identifier from the university hospital or the hospital or the register, the data provider institute. I omitted the template identifier because it's not necessary for the consent. So what happens in the next step with your data is the idea of the de-identification of this consent that you send. So the de-identification does two things. The one is, as we auto-configured all our the whole pipeline with the ontology, we know where are dates. So everything that is a date is affected by the de-identification. And here we apply some date shifts. Another thing we do is we exchange the subject pseudo identifier, or this identifier here, this one, which can be identifying thing from the register or from the data provider. We exchange this one with a pseudonym. So it's not a hash or any function that we applied. It's really a newly generated item, which is a pseudonym. So both of these are there, and we know where they are from the ontology. So we can apply this. And how does that work? So every project that you have, you can assign a certain range of an offset. And every date of the same patient gets the same offset applied. So it's, for example, you take plus minus 30 days that you do. So for every patient you sample one time, and then you apply the same offset, maybe 1 day and 8 hours, for the same patient for all the dates that it is. So we take the patient and just shift it to a constant thing. So the whole journey of a patient. One other very important thing is these random pseudonyms that we add for the pseudo identifier, and these date shifts that are actually taken for this patient. They are available for the data provider for archiving purposes. And one other thing is, if you send, for example, the patient again because of an error in the data or a new item that you had in the data, then it's idempotent. So the exact same date shift or exact same pseudonymization is applied to the exact same patient that you get at the input. And here we also now have the de-identified data. So what do we do next? We want to transform the data into RDF. So that's or you could consider something like a magic thing, but it isn't actually that magic. So you can think of, we create a so-called fill in the blank, or in German, a Lückentext, but we create that one because we know how the final data should look like, so the full text, and we know how the input would look like. And it's just this task here is how to get, let's say, from the input to the final output. And it's defined by the ontology, how that should look like. So we take here the object representation, and I just highlighted some things in colors. So the status code has something like a terminology ID. The date has datetime, has a datetime object, and the pseudo identifier has a pseudo ID, and the data provider institute has a data provider institute ID. And you can think of everything here in black on the lower part of this slide is what we generate from the ontology. So we know how it should look like, and we leave out blanks for the data to be actually filled in there. And we take then the object or the tabular representation that the data provider uploaded, we de-identify it, and then we take here the right elements and put it in this blanks of the text. And finally, we have very nicely looking RDF. Now with the RDF, you could actually supply something wrong. For example, something wrong, like a wrong status code for a consent or something similar or something different. So it needs to be validated. But why do we actually need to have a validation? Doesn't the ontology give us that one? And here's also cropped down version of the payload visualization here. So we see the status code has cardinality, and it has also some other things, but the ontology is a description. And I like this definition here quite well from Tom Gruber, that the ontology is a description. It's not about a validation thing. So it doesn't enforce that you actually have the instances being or adhering to this description. And for that one, we need a validation. We're very lucky that we have in the SPHN ontology, we have a lot of information already inside. So as said, the cardinality is there, and we have also the status code restriction and these kind of things. So what we would need to do is make a translation from the description, how it should be, or how we think it is right, to something that enforces that if it is a consent, then it has to be like that. And it has to adhere to that one. And here I picked again the same example of the status code with the cardinality. Cardinality here means it is optional, but at most one. So it can be absent, but it has to have, if it's there, it says most one. And if it's there, we also have here a restriction on these values. So we either only allow these 3 SNOMED codes, and we also don't allow children of these SNOMED codes if they exist. And in the lower part, it's a real excerpt. It's a little bit redacted from the actual shackle representation that we use to enforce these things. So here you see that on the status code, we have a property restriction. It says it is at least occurring 0 times and most occurring 1 times. And if it's occurring, then it has to end in instances of these 3 SNOMED values. They're actually changed in order, but they're the same 3. The other thing what we have, it's redacted here as well, that we also check the descendants of the given classes are not allowed. Here we have another message that is there. So everything that you see in the description is translated to an enforcement validation rule. And by this, I can hand over to Katie, as you now have quite a good knowledge about what the SPHN connector does as its core principles.
So now you may be curious about the SPHN connector because you probably want to deliver some data for one of the projects, or you just want to participate in the SPHN project universe. So when you want to start using the SPHN connector, there's a couple of things you probably would need beforehand to organize, which takes some time to organize. So one thing is, of course, access to your source data or the data warehouse. So depending on how you organized, it's more complicated or less complicated, but collecting the data, especially for a bigger hospital, is probably quite a challenge. Then what you shouldn't forget that your source data has usually different mapping. For example, for the gender, you probably use M or F, or you write männlich or weiblich or female. And the codes for SPHN are actually SNOMED codes. So you have to come up with mapping table for all those codes where you then have to map from your source data to the SPHN connector defined value set. And this can be quite consuming. Depends on what kind of concept it is. Probably the gender is a simple one, but if you have like measurement methods where you have like really complex SNOMED hierarchy where you can select what kind of measurement you're actually providing here. So this, at the moment, we don't really have a solution for providing these mappings. Might be in the future something we can do, but this is something you would have to organize. Usually you can do it with a simple relational database table where you have like 1 column source, 1 column the SPHN value set. Then with this, you probably also, as mentioned, you would like to have some kind of a data mart or where you collect the data so that you have everything in one place. And the data mart we, for example, at USZ, we use is in kind of a 99% the same structure like the database in the SPHN connector where we copy the data to. So we do a lot of grouping of the data into different tables and columns already into our data mart, so that at the end you just can copy kind of one-to-one from this data mart into the SPHN connector. For this one, we also have another solution. There's a Git repository which has a SPHN connector integration software, which is written in Python, which, for example, could be used as a base. But depending on what kind of infrastructure you have, you might already have some tools you make or use for it. And also going forward, especially for smaller data providers, we are also enhancing the SPHN connector to make life here easier. For example, in the future, you will be able to provide an Excel file, of course, only if you don't have very huge data, otherwise it gets a bit tricky. Then I said this is the program to ingest. At the moment, we have JSON or tables, which we support. Then, of course, beside the SPHN connector, you probably would need a tool to copy the data or transfer the data from your internal infrastructure to the project spaces on the Biomed IT. And for this, Biomed IT has created this set tool, which is a transfer tool which does encrypt the data and transfers it to a project space based on some rule you give, and then there's a person who can decrypt it with a dedicated key. So it's a very safe method how to transfer the data. So this is kind of the prerequisite you have to think about when you want to use the SPHN connector. Then what do you actually have to do as mentioned before, as a SPHN connector needs an infrastructure. So you probably would have to find a server. Most of us use a Linux server. It's probably the most performant one to run the SPHN connector on if you have a bigger data set to deliver, but we also provide SPHN connector for Windows, and it's also running fine for normal installation. But it needs to have a special Windows installation. So you cannot just take a Windows 10 client laptop without certain prerequisites. So then the data preparation, as I said, the mapping of codes is one thing, but then you would also have to kind of think how you define the cohort, as a which data you select, as a which patient, maybe which lab codes, also which scoring systems you need to provide or you want to provide, and also the list of concepts. So you need to think about this one and build your data mart according to this one. Then you will go and extract the data from your system into the data mart. And then you also have to be kind of thinking about what I do with the consent. Do I load everything into the data mart and filter afterwards, or do I just take the one which are kind of consented? Because later it can change, you know. So you maybe start off with a patient which has consented and later he rejects it. And therefore also the SPHN connector is designed to run on a patient base. So you can do easily incremental loads by patient. So if you have the first 500 patient, and then comes some new ones. You just ingest the new patients, and if you have an old patient which has new data, you would ingest this one too and reprocess it. So it's not like a task where you collect all the data for 50,000 patients and then transform everything. So you can do it on the go. Then the operation of the SPHN connector, as I think you would have to see how you ingest the data into the SPHN connector. There's the tools and frameworks you can use. But then there's also SPHN connector you manage with through an API. So the only thing you have direct contact actually is with the database if you use ingestion into the database and not the JSON. Everything else you do through a web. Also, there's a web endpoint which you can either in theory directly use in the web browser, but this is not really a production way. So what we also do in our case, for example, we have the same Python program who ingested the data into the connector actually manages the pipeline. That means you have to kind of start the pipeline. You have to check if it's running. Then you would like to see how many patients actually were validated correctly. And then you would download again with the endpoints the data so that you can send it afterwards. And this is all done with this API endpoints. But yeah, this needs some time how to organize. Probably we will provide some command line tools for the future, but at the moment we don't really have them, but we are thinking about them. Then, so if you're interested now in the SPHN connector, so how do you start? So what we usually propose is to have an onboarding meeting where we can discuss your special setup, the context of the project you probably would like to provide data for, and we can consult you also with the next steps. As a preparation, I would suggest you use the installation guide and the user guide, which gives you a lot of information. You can obtain these from us. They are actually in the Git repository, and we can provide them beforehand. And then if you really want to have this onboarding meeting, the best way to organize this one is send an email to dcc@sib.swiss so that we can get in contact with you and organize a date and all the preparation for it. So how to get started to prepare the data. Also, after the onboarding meeting, we will go through with you some other important things where you can read. It's like the semantic spreadsheet you probably would like to download because some of them, some people would like to see it in an Excel version, but then there's also the ontology visualization, the pilot. If you're more a visual person, then there's the read the docs. There's a lot of about the semantics described and how you implement certain things, and you find the documentation of example pipelines, mainly from the first phase of how we did it. Also for the curious ones, how it was done in the phase 1 of SPHN. And then the terminology mapping is, I cannot repeat it again, is something you probably would have to invest some time because it's not simple to find sometimes the right mappings. Then as mentioned, there's optional additional Python template to copy the data into the SPHN connector. And I'm sure we will also find some other data providers, university hospitals, which are helpful to share their knowledge or maybe part of the source code they use if they use something else than Python so that you can copy the data into your SPHN connector. We also provide you with some links for these documents I mentioned before. Some of them, they're not openly available, for especially the Git. You probably have to register first so that we can authorize you for the Git lab. But in the future, the SPHN connector we plan to make open source, so it will be easily accessible for everyone. Yeah. And having said this one, I would like to thank you for participating in today's webinar. And I think I hand over now to back to Sabine for the Q&A.